Morning, Eli.
Good morning.
How are you this morning?
Good. How about you?
Pretty good. I'm going to start working through the homework and try to work through about 3/4 of it at least. Making sure that I do enough examples for each of them. I'm going to start with number 1. And unless there's some that you have a particular question over. So just stop me if there's one that you rather me do that I'm not doing. But
you can just start on 1.
Okay. So I'm going to slide my leading coefficient over first. I'm just going to follow all of the steps that are highlighted on the notes yesterday. And step number 1 is always to slip or slide that leading coefficient down to the C. So basically what you're doing is multiplying A times C. And then you'll rewrite that trinomial. So the new trinomial is going to be x squared plus 5x times or plus 4. So oftentimes you'll see a little diagram that will be like AC, which is 2 times 2, which is 4. And then you've got up here in this X diagram with a B in the bottom, like this, like the 5. And so what they'll talk about is that it's A times C. That's the slide part. And now when you get ready to factor, they're going to talk about 2 factors that multiply to give you 4, that when you add, give you 5. So that's going to be 4 and 1. I don't know if that would help you process it out a little better. Like a little diagram so that you're thinking through. So this is the multiplication part at the top, and this is the adding at the bottom. X plus 1. So there's the 2 factors that multiply to give you 4, because 4 times 1 is 4, and 4 plus 1 is 5. And now, so we slide here, and now we're going to divide here. You're going to, because we slid and we multiplied the 2, so now we're going to divide the 2. And 4 divided by 2 is 2. And this doesn't turn out to be a perfect integer. So this is where we bottoms up. So that's going to be 2x plus 1. So that's your final answer for that one. Number 2, slide. So that gives me n squared plus 5n plus 6. So now if I was doing the little X diagram, I've got AC up here, which turned out to be 6, and my B down here, which is 5. So what 2 factors of 6 multiplied together, when I add them, give me 5. That's going to be 2 and 3. So n plus 2, n plus 3. So now I'm going to divide this by 3 and this by 3, because that's what I multiplied by when I slid. Okay, so I'm going to divide by 3, because you divide by whatever you multiplied when you slid. So the 2/3 is not a perfect integer. So that I'm going to do bottoms up. So that's going to be 3n plus 2. Now 3 divided by 3 is a perfect integer, and that's n plus 1. So your final answer is 3n plus 2 and n plus 1. Now, just to ask a couple of questions, some of you came in a little later and may not have heard my first time when I was doing the little X diagram. I don't know if that makes it more confusing or if that helps a little bit so that you're seeing that top AC is where you multiply, and the bottom, that B term, the middle term, is where you're adding or combining. So the two side terms should multiply to give you the top and add to give you the bottom. Does that help you guys or make it worse? Any responses?
It helps.
It helps? That helps you? You like seeing the X?
Yes, ma'am.
All right. Okay, so for number 3, very first step is what?
Slide.
Slide. Good job. Thank you, Grayson. Slide. So I'm going to slide down and multiply 2 to 5. So then that's going to give me y squared plus 9y minus 2 times negative 5 is negative 10. So now I'm looking for, I'm going to draw my x. I'll erase it. I'm going to draw it down here. I'm looking for two terms that multiply together to give me a negative 10 that when I add them, give me a positive 9. That's my B term down there. So 2 that give me a negative 10, that give me a positive 9. That means one is going to be negative, one is going to be positive, and the bigger one is going to be positive. So what would those two be?
One and 9? Wait, no, that doesn't make sense.
Multiply to give me a negative 10. Remember, the multiplication is the top.
Would it be a positive 1 and a negative 10?
It'd be the other way around because the bigger one has to be positive. Right?
Oh.
Because you find the difference and give the sign of the higher one. And what is the sign on the 9? Right?
Positive.
Yeah. Does that make sense?
Yes.
Okay. So now we have y plus 10, y minus 1. So now we slid by multiplying up here a positive 2. So now we're going to divide out that 2. Whatever you multiplied in the slide step, that's what you're going to divide by in the divide step. So you divide by 2. And 10 divided by 2 comes out to be a positive 5. That's a perfect integer. So we'll just write it like that. 1/2 is not. So this is where we'll bottoms up. So 2y minus 1. So my final factors for number 3 are y plus 5, 2y minus 1. So what's my first step on number 4?
Slide.
Slide. Good job. So I'm going to multiply this 3 times 2. And that is
6.
6. Good job. So now I'm going to look for two factors that multiply together to give me 6. But when I add them, give me a -7.
Write that out to the side.
-6 and +1.
-6. Well, no, and -1.
Oh, yeah,
Because
sorry.
a negative, that's okay. A negative times a negative is a positive. And a -6 and a -1 combine together to give you a -7. So now we have G minus 6, G minus 1. Okay. Now we're going to divide. And what do we divide by?
We're here.
Whose background noise is that?
I don't know.
Oh, we made it. Yay. I said not for 5, so that would make me be here in about 10. So, so we're
Hey, Eli, you might have to mute yourself. I think it might be Eli's, but I'm not
Yeah,
sure.
his mic is off. I mean, on.
Yeah. Thank you, Eli. Sorry. Oh,
Oops.
he went away. That makes me feel bad. I didn't want him to go away. All right, so now we're going to divide by what we slid down and multiplied by, which was what? 3. So divide by 3. All right, so 6 divided by 3 is 2, and that's a perfect integer. 1/3 doesn't come out to be a perfect integer, so you're going to bottoms up. So 3G minus 1. So your final answer for number 4 is G minus 2, 3G minus 1. So number 5. Slide. Multiply by 2. So that's going to be K squared minus 11K plus 30. So looking for two factors that multiply to give you 30, that when you combine them, give you a -11. So the 30 is positive, and the -11 is obviously negative. So that tells me that my two factors are both going to be negative, because the only way to get a positive result from multiplying is to multiply two positives or two negatives. So what two negative numbers multiplied together give you a positive 30, but when you combine them, give you a -11?
-6 and -5.
-6 and -5. Good job, Grayson. So that's going to be K.
I went ahead and tried number 5 on my own. I think it's starting to make more sense.
Well, good. I'm glad to hear that. All right, so now we've come up with our factors. Now we're going to divide. What number do we divide by?
2.
Right, because that's what we multiplied by when we slid down, isn't it? So we divide -6 by 2, and that comes out to be a perfect integer. That's 3. So we can reduce that one that way. But negative 5 divided by 2 is not a perfect integer, so you bottoms up. So that's going to be 2k minus 5. Did Eli come back?
No.
Oh, that makes me feel bad. All right. Number.
I got number 5 right on my own.
Yay, number 6. I'm glad to hear that, Grayson. That's awesome. So the first step is to slide. And we're going to multiply by 9. So that's going to give us p squared plus 6p minus 72. So we're looking for two factors that multiply to give you 72, but when you add them, give you a 6. What factors would those be? One's going to be positive, one's going to be negative, and the bigger of the two is going to be positive. What would that be?
No idea.
Well, think about your multiplication facts, some of those bigger ones. Y'all struggled with these after 10, right? What are some other things? I'm sorry?
Nothing.
Would it be 6 times 12?
6 times 12, it would be. Who said that?
Bailey.
Yay, Bailey. Good job. I thought that was you. Okay, so, and the bigger number is going to be positive, and the smaller number is going to be negative. So P plus 12, P minus 6. So now the next step is to divide. And what do we divide by?
9.
9, because that's when we multiplied during the slide step. We multiplied by 9. So in the divide step, we're going to divide by 9. Okay? So now we've got 12 over 9, and we've got 6 over 9. Well, that doesn't come out to be a perfect integer, but it is reducible. So 3 goes into both 12 and 9, so that's going to reduce to 4/3. And 3 also goes into 6 and 9, so that's going to reduce to 2/3. Those still aren't perfect integers, but will bottoms up once we get them into their smallest form. So the final answer is going to be 3p plus 4 times 3p minus 2. All right, I'm going to let you all do 7, 8, and 9 on your own. And I'm going to move on down to number 10, where you have to factor out each of the GCFs first. So when you look across on number 10, we can see that there's a common factor, greatest common factor of 2. So the first step is going to be taking out a 2 out of each term. Now we can't reduce it any further, but our A is still greater than 1, so we're going to slide by multiplying by 4. Still have to bring that down though. And now we've got x squared minus x minus 20. So what two factors give you a negative 20? When you combine them, give you a negative 1. That's going to be x minus 5 and x plus 4. Then we're going to divide, and we divide by 4 because in our slide step, we multiplied by 4. So our divide step, we're going to divide by 4. Do not get that confused with your greatest common factor, which is outside of that. And so now 5/4 does not reduce, so we'll bottoms up. So your final answer is going to be 2 times 4x minus 5 times x plus, and then 4 over 4 does reduce to 1.
So on number 7, I know that like it's 9 and 4, the two numbers that get you 13m and 36.
Okay.
But I don't know which to make positive and which to make negative. That always confuses me.
Okay, well, if the last number's positive, they're both going to be negative, right? Because the only way you can multiply and get a positive number is to multiply 2 negatives or multiply 2 positives.
Thank you.
So you have to think about, you know, what am I trying to, what is the end result of what I'm trying to get? Am I trying, you know, like if it was a negative number and the B was negative, then you know there's going to be a negative and a positive. And since the B is negative, that means the bigger of the two is going to be negative. Right?
Yeah.
So you just kind of think that through. And I'm going to erase some of my work here so that I can, well, because I'm trying to figure out where to, I'm going to erase this work right here.
Hold on a minute. Wait, you're good. I just need that last answer part.
Yeah, I know. I was going to rewrite that in the box. 2, so 4x minus 5, x plus 1. I'm going to try and write smaller. Struggle's real. All right, so on number 11, the greatest common factor, 6 won't go into all of them, but 3 will go into all of them. So the greatest common factor is 3. So I'll take a 3 out of each individual term. So that's going to be 2a squared plus 3a minus 9. And now I have to slide my 2 down to the negative 9. Can't forget to bring my greatest common factor down, though. You don't want to leave that out. So now I'm thinking of 2 factors that multiply together to give me a negative 18 that when I combine them, give me a positive 3. So that means to get a negative, one has to be positive, one has to be negative. And then to find out which one gets the positive sign or the negative sign, down here, this tells me the bigger one has to be positive. Because the end result, you find the difference and give the sign of the higher one, the one with the larger absolute value. So in this case, it's going to be the positive factor. So what are the two factors that multiply to give me 18 that when I subtract them, give me 3? Two factors that multiply to give me a negative 18 that when I combine them, give me a positive 3. Anyone? No one knows?
3 and 6.
Yes, 3 and 6. Thank you. And the bigger one is going to be positive. So that's the 6. So positive 6 and negative 3. So in the first step, I slid down and I multiplied by what? Anybody there? What did I multiply for when I slid down? What did I multiply by?
6.
6.
No,
2.
right here. No.
2.
Yes, 2. Good job. I multiplied by 2 in that step. So I'm going to divide by 2. Right? On this step. It's very crucial when pulling out that greatest common factor that you remember whatever you slid down and multiplied by, that's what you divide by in this step. Just like in previous steps. Don't get confused with the GCF. So I'm glad we're talking about this out loud so that you guys can participate. So 6 divided by 2 is a perfect integer. That's a plus 3. And now bottoms up, because 3 over 2 does not come out to be a perfect integer. So we have 2a minus 3. So your final answer is your greatest common factor of 3 times a plus 3 times 2a minus 3. All right, number 12. The greatest common factor that can be taken out is a 4. 4 goes into 60 15 times. 4 goes into 4 1 time. And 4 goes into 8 2 times. So now the next step is to slide. Oops, I drew a bad arrow there. I'm sorry, because that could be confusing. Slide your 15 to your 2. So slide to multiply by 15. So now I have x squared plus x minus 30. So I'm looking for two factors that give me a negative 30 when I multiply them, but a positive 1 when I add them. What would those two factors be? Grayson, how about you try? What would give me a negative 30? When you multiply them, but when you add them, give you a positive 1.
I don't know. There's 3 and 10, 6 and 5,
Okay.
1 and 30.
Okay, so what do you get? 6 and 5 when you combine them, because one has to be positive, one has to be negative in order to get a negative. What do you get?
1, so it's 6 and 5.
Right. And which one has to be positive?
6.
Yeah, because it's the bigger one, and this is positive. So it's positive 6, negative 5. Good job. I know you said that you struggled with that a little bit, so I just wanted to process it out loud because I know that helps you. So if we're thinking about it out loud, sometimes it does help. When we slid down, what did we multiply by?
15.
15. So that's what we're going to divide by on this step, right? So we divide by 15. So we've got 6 over 15 and 5 over 15. Well, that's not perfect integers, but those can be reduced, right? So 3 goes into both of those. So we get 4 times x plus 2 over 5. And x minus 5 goes into both of those. That's going to be 1/3. So now we'll bottoms up. So my final answer for number 12 is 5x plus 2, bottoms up over here, 3x minus 1. And I'll give y'all a minute to write that out.
So it's basically the same thing as what we were doing above, but just finding the greatest common factor.
Yes, sir. That's it exactly. That is it exactly.
That shouldn't be too hard.
Nope. Not too bad at all. Once you find that greatest common factor, it's not bad at all. All right, I'm going to try to erase some of this work here and write the answer down there. I'm going to do one more of this type and leave y'all to do the last 2, but y'all can pick 13, 14, or 15, whichever one you want me to do.
The hardest one.
I don't know which one that is. Bailey, do you have a preference?
I started 13 and I'm kind of having trouble with it, so maybe 13.
Okay. All right. That's what I'll do. I'm going to rewrite the answer to number 12 and then move on to 13. 4, 5x plus 2. This is the final answer for that. 3x minus 1. Okay. The greatest common factor on number 13 is going to be 8 because 8 goes into all 3 numbers. So I'm going to factor out an 8 first. And now I'm going to slide that 2 down. Multiply by the 2. And that's going to give me 8 times x squared minus 3x plus 2. So I'm looking for 2 factors that multiply together to give me a positive 2, but when I add them, give me a negative 3. Well, the only way I can do that is to have 2 negatives, because to get a positive integer, I have to multiply two negative integers or two positive integers. And to combine and get negative, it has to be negative. Because negative times a negative plus a negative gives you a bigger negative. So this is going to be -2 and -1. So x, and I don't know what it is, but I will tell you, the smaller the numbers, sometimes with factoring, like factoring this 8 out up here and getting that 1, I don't know. Sometimes that gets to be a little confusing. So I can see sometimes those small numbers trick us worse than the big numbers. All right, in your slide step, you multiplied by a 2. So now on our divide step, we're going to divide by a 2. So 2 divided by 2 is 1. 1/2 does not reduce to be a perfect integer, so we'll bottoms up. So my final answer is 8 times x minus 1 and 2x minus 1.
How do you know when or what number to put to divide the two sets?
You mean on the divide step, like right here?
Like the step you just did on the divide step, I guess.
Okay, all right. Whatever you slid down and multiplied by.
Okay.
See, that's why I've been writing slide with a little 2 in parentheses. And you'll see up here on number 10, I wrote slide and a little 4 in parentheses.
Gotcha.
So, and that's my reminder to myself particularly when I'm pulling out a greatest common factor. I don't want to get that greatest common factor mixed up with what I slid down and divided by, or slid down and multiplied by, because on my divide step, great question, my divide step, you want to divide by whatever you slid down. So when I slide, sometimes to make myself remember, because when you get all mathy and you start writing all these numbers, you might forget what you slid down and multiplied by.
Mm-hmm.
So if you make yourself a little note right next to that, and I'm going to be honest with you, yesterday I was tutoring somebody and I was factoring trigonometry things like sine and cosine, and I use my arrow every time. Still, I had to slide and divide. And I still use my arrow and write my little number and on my own personal work. Because when you're factoring things out and you start writing a whole bunch of numbers, it's easy to like glance back at your prior work, and you might glance back and see this 8. Well, you want to make sure that whatever you slid by is what you divide by. So I always write myself a little note that's slide 2, divide 2, slide 4, divide 4. Does that make sense? Does that help?
Yes, ma'am. Thank you.
Oh, no problem.
Isn't the greatest common factor in 14 5?
Indeed it is, sir. It is 5.
Thank you. I'm trying to do last 14 and 15 and see if I can do it on my own. I'm not sure.
Okay. Let's see. Kennedy, do you have any other questions? Because I know you came a little later, but maybe you came for that specific question. I don't know. Do you have any questions? And Kristen, do you have any questions?
Just on the ones above, like if you can't divide it by the same number for each one, do you divide it by the two separate numbers, or do you just leave it alone and just write it as it is?
Like, let's take a look at an example specifically. which one would you want to, like number 4?
We can
Let's
do number 8 because I think that one is
Okay.
one that I know
So,
I probably messed up on, but
okay, so you slide and you multiply by 3, right?
Yep.
So c squared plus 2c minus 48, right? So, and I've been doing this x. I don't know if you showed up for this, but this tells me at the top, what 2 things do I multiply by to give me a negative 48 that when I combine them, give me a positive 2? Well, to get a negative, I know I have to have one positive integer and one negative integer. But I know the bigger one has to be positive. So what 2 integers multiply together to give me a negative 48 that when I put them together, give me a positive 2?
8 and 6.
And so it's going to be a positive 8 because we said the bigger one had to be positive, and negative 6. So I've got c plus 8.
And then you would divide that by 3. And you can do that for 6, but you can't do that for 8.
Exactly. Good job. So I'm going to divide by 3.
So would you just divide what you can and then leave the other alone?
Bottoms up. That's that bottoms up step. 3c plus 8. When it's not a perfect integer, you bottoms up.
For all of it?
Well, that's what we've been doing. Like, you might, if you have a chance to go back and watch the first part of Math Lab, if they don't reduce perfectly, like even on let me finish this one for you so we don't get confused. Yeah. This is going to be c minus 2 because it does divide perfectly.
Okay, that's what I needed to know. Thank you.
And so if it's a perfect integer, you write it. If it's not a perfect integer, you have to reduce it. Like on number 6, see you've got 12 divided by 9. That's reducible to 4/3, and 6 divided by 9 is reducible to 2/3.
Okay.
But it still doesn't come out to be a perfect integer. So then you bottoms up. And I got 3p plus 4 and 3p minus 2. So you have to get the fraction to its lowest terms. And then if it still won't come out to be a perfect, pretty clean integer, you bottoms up. So slide, divide, simplify, bottoms up, if necessary. Does that help or not really?
Yeah, I did. Yeah.
Okay.
Thank you so much.
You're welcome. You only bottoms up if it's not a perfect integer.
I got number 8 correct.
You did? Good job. Good job. Any other questions? I'm so proud of you, Grayson, and I appreciate everybody showing up to Math Lab. Does anybody else have a question for me or a clarification or anything like that?
Nope, thank you.
You're welcome. You're very welcome. I appreciate y'all coming to Math Lab. I will post the recorded Math Lab if you need to go back and look at it. I also posted on Google Classroom an Ed puzzle that goes through 3 or 4 more examples. Lots of examples for this stuff, okay? Because it just takes a lot of practice. And I know it's crazy, but write out all your steps. I mean, you don't have to write the word slide like Miss Sparks does. I do that for Math Lab specifically. But when let me just do this. Like on this one, if I were doing this like in real life all by my lonesome, I would write this arrow and then I'd write a 6 and circle it. And then write m squared minus 13m plus 36. And then that way, when I have that little 6 next to my arrow, it reminds me that when I go to the divide step, that's what I'm going to divide by. Does that make sense?
Can you do number 7?
Yep. So I'm looking for two factors that multiply together to give me a positive 36 but a negative 13 when I add them. That's going to be m minus 9, m minus 4. I'm going to divide them by 6. That's reducible. 3 goes into both of those. So it's going to be 3 halves. And that's going to be 2/3. So, but they're not perfect integers. So I'm going to swing them up, bottoms up. So my final answer is going to be 2m, sorry, that's written right over that, minus 3, 3m minus 2. I'm going to try and write them over here.
I think I did all the work right. I think I'm just not simplifying the right way.
Oh, okay. So you're getting the factors, but once you get to the fraction part, maybe not getting that step.
Yeah, I think so. And I think I'm just second guessing myself of if it can be reduced or not. So.
Oh, okay. So how did you do on number 7?
7, I think I did all the work right, but I ended up with 6m minus 9, 6m minus 4.
Okay, I got you.
Yeah.
Okay, so instead of reducing at this step here.
Yeah, I just put it into bottoms up.
Okay. All right. The one key thing I think on this particular thing is recognizing when you can reduce a fraction. And if that's something that has been a more difficult concept for you in the past, which for a lot of people it is. I mean, that's not a very uncommon thing in math at all. So that's one of those things. What I would, because then you can kind of look at it and you can see, that can kind of reduce a little bit. I don't know. That will just come maybe with practice. Because that is probably one of the more difficult things. It's interesting. How I was taught to do this basically was actually worse than this because you just had to guess, essentially try multiple things over and over again, like take all the factors of 6 and it was worse than this, but this would probably be the hardest part of that is detecting when a fraction is reducible. I mean, it's pretty easy when it's like 3 divided by 3 or 9 divided by 3, and it's something that's a straightforward integer. But yeah, it's a little more tricky when it's 9/6 or 4/6, something like that. I think number 9 actually is like that a little bit as well. So try that one on your own. And see what you come up with, and we'll go over that one in class tomorrow. We'll do 9, 14, and 15 in class tomorrow.
Hey, Kennedy, if you need extra help after math lab, you can call me.
Okay, sounds good. Thank you.
Oh, that's nice. I love it when you guys help each other out. Such a huge blessing. Any other questions? Well, I will definitely post the recorded version of the math lab. And we'll go over the rest. We'll go over the last 3 that we didn't cover in math lab. We'll go over those in class tomorrow. But you guys definitely try it on your own and come to class with questions tomorrow. Okay? And know that I love y'all and praying for you.
Thank you.
Have a blessed day.
You too.
Bye-bye.